Welcome to a slow, beginner-friendly lesson on installing the AWS CLI and connecting your laptop to your AWS account, made for absolute beginners. The bridge is built today. In the previous lesson, you created an Amazon Web Services account and learned what the cloud is. Today we connect your laptop to that account. We install a command line tool called the AWS CLI, we create access keys in the console, and we store them on your machine. Then we run one command that proves the connection works. By the end of this lesson, you can type a command in your terminal and reach your AWS account. That connection is what lets us deploy Python code in the lessons ahead. 2 worlds, 1 connection. Where are you? You have an AWS account. You open the management console in a browser and enabled multi-factor authentication. That browser interface is great for clicking around, but real developers work from the terminal. The AWS command line tool, called the CLI, lets you type commands that reach your account. More importantly, it lets your Python scripts reach your account through the Boto3 library. Today we install the CLI and prove the connection works. From browser to terminal, we continue with the same workspace from the previous lesson, Cloud Foundations. Inside lives the Cloud_Foundations package with a check_AWS script. Today we fill in that script so it calls AWS and prints who you are. If you skipped the previous lesson, go back and create this project first with UV in it. The structure is small on purpose. 1 package, 1 script, 1 test folder. We keep it tidy because cloud work gets complicated fast. The same tidy workspace. Move into the Cloud Foundations project. Confirm that Boto3 is installed by running UV add Boto3. If it is already there, UV simply confirms it. Here is a common point of confusion. Boto3 is the Python library for talking to AWS. The AWS CLI is a separate system tool written in Python but installed globally, not inside your project. They share credentials. Once you configure the CLI, Boto3 reads the same configuration automatically. So we install both, Boto3 in the project, and the CLI on your system. 2 tools, 1 shared config. Here is the order of operations for today. First, install the AWS CLI at the system level, not with UV, but with a system package manager. Second, create access keys in the AWS console. Third, run AWS configure to store those keys on your machine. Fourth, verify the connection with AWS STS get caller identity. Once that works from the terminal, we run the same logic from inside our Python project with UV run python-m cloudfoundations.check AWS. 4 steps to connect it. Your laptop and your AWS account are 2 separate worlds. Today we build the bridge between them. The bridge between worlds. The AWS CLI is a command line program that lets you manage your AWS account from a terminal. You install it once, and then you can type commands like AWS Lambda list-functions or AWS S3ls from any terminal window. Every action you can do by clicking in the web console has an equivalent command. The advantage of the command line is speed and repeatability. You can put commands in a script and run them again and again. For this course, the CLI is how we deploy and invoke Python Lambda functions. Faster than clicking, install the AWS CLI with the package manager for your system. On a Mac, whether Apple Silicon or Intel, use Homebrew, brew install OSCLI. On Windows, use wingit install aws.oscli. On Ubuntu or Debian Linux, use sudo apt install oscli. The installation takes a minute or 2. When it finishes, the AWS command is available in any terminal window. If brew is not installed on your Mac, install Homebrew first from brew.sh. We assume you already have it from the earlier UV lessons. 1 install command. Verify that the installation worked by typing AWS version. You should see a line starting with AWS-CLI, followed by a version number, then details about the Python version and operating system it was built for. On an Apple Silicon Mac, you will see Darwin/ARM64. If you see command not found, the most common fix is to close and reopen your terminal, or restart your shell so it picks up the new command. Once you see a version number, the CLI is installed and ready to configure. Check the version. Here is the path we walk in this lesson, laid out as a clear set of steps. First, install the command line tool. Second, run AWS configure, which asks you 4 questions. Third, you enter your access key, your secret key, your region, and your preferred output format. Fourth, those values are saved in 2 files inside a hidden folder called .aws in your home directory. Fifth, you verify the connection by running AWS STS get caller identity. When that last command returns your account number and username, every step in the chain worked. From install to verified. Access keys are the password your terminal uses to prove who it is. Guard them like a house key. Guard the keys. Before we run AWS Configure, we need access keys. In the AWS console, search for IAM and open it. Click Users, then click your username. Open the Security Credentials tab. Scroll to Access Keys and click Create Access Key. Choose Command Line Interface as the use case. Amazon shows you two values, an access key and a secret access key. Copy the secret key immediately, it is shown only once. If you lose it, you must delete the key pair and create a new one. Paste both values somewhere safe, like a password manager, before continuing. Shown only once. Now run AWS Configure in your terminal. It asks 4 questions. First, your AWS access key ID, paste the access key you just copied, the one starting with AKIA. Second, your AWS secret access key, paste the long secret value. Third, your default region name, type US East 1 for this course. Fourth, your default output format, type JSON. As you type the secret key, nothing appears on screen. That is normal. It is a security feature. Type it carefully and press enter. 4 questions. When you finish AWS Configure, your keys are saved in a file called credentials inside a hidden folder called .aws in your home directory. Open it and you see what is shown here, a section in square brackets called default, followed by your access key and secret access key. This is the file that the CLI and Boto3 read automatically every time they connect to AWS. You almost never edit this file by hand, AWS Configure writes it for you. But you should know where it lives, because it contains your secret key in plain text. Plain text on disk. There is a second file in the same folder, called config. It stores your default region and your default output format, but not your keys. So the .aws folder holds 2 files with different sensitivity levels. The credentials file is highly sensitive, it contains your secret key. The config file is safe to share, it only says which region and output format you prefer. Knowing the difference matters when you write a .gitignore file later in this lesson. You ignore the credentials file always. The config file is less dangerous, but most people ignore it too. Region and output only. Now the moment of truth. Type AWS STS get caller identity. STS stands for Security Token Service. This command asks AWS a simple question: who am I?
If your credentials are correct, AWS replies with a JSON object showing your user ID, your account number, and your ARN, a string that identifies you.
The account number is the 12-digit number you saw when you created your account. If you see that number, congratulations, your laptop is connected to your AWS account. This command is the hello world of the cloud. The hello world of AWS. One command proves the bridge works. When you see your account number, you are connected. The proof is your account number. You can store credentials for more than one account. Run AWS configure profile work to create a second profile called work. Answer the same 4 questions, but this time with the keys from your work account. Now your credentials file has 2 sections, default for your personal account, and work for your work account. This is how consultants and engineers switch between clients without rerunning configure each time. You set it up once, then choose the profile when you run a command. One CLI, many accounts. To use a profile from the command line, add -- profile work to any AWS command. Without that flag, the CLI uses the default profile. In Python, Boto3 works the same way. When you create a client with Boto3.client, it reads your default credentials automatically. To use a named profile in Boto3, you pass profile name equals work to the session. We use only the default profile in this course, but knowing named profiles exist saves you confusion later when you have a work account and a personal account. Pick per command. The default output format is JSON, which is easy to read and easy to parse in Python. But you can override it per command with -- output. Table format draws a nice human-readable grid. Text format returns plain values on one line, which is useful when you write a shell script that pipes the output into another command. YAML is another structured format. For this course, keep the default JSON, it matches what your Python code receives from Boto3, so the terminal and the script stay consistent. JSON is the default. This is the most important habit in this lesson. Never commit your credentials to a Git repository. Create a .gitignore file in your project root and list anything that might contain secrets, the .aws folder, .pem key files, a credentials.json file, .env files. The .aws folder in your home directory is outside your project, so Git cannot reach it by default, but if you ever copy credentials into your project, the gitignore catches them. Automated bots scan GitHub every second for accidentally committed keys. If they find yours, they hijack your account within minutes. Treat your secret key like your bank PIN. Bots scan every second. There is an alternative to the credentials file: environment variables. You can export AWS_access_key_ID, AWS_secret_access_key, and AWS_default_region in your shell. The CLI and Boto 3 read these too. This approach is common in C/CD pipelines and inside Lambda functions, where you cannot keep a credentials file. For local development, AWS Configure is easier and safer, because the file lives in your home directory instead of your shell history. We use AWS Configure throughout this course. For C and Lambda, quick self-check. Can you explain the difference between the AWS CLI and Boto 3? Can you name the two files that AWS Configure creates? Can you state what AWS STS get caller identity returns on success? Can you say why a .gitignore file matters for credentials? If any feels shaky, rewatch the matching part. The connection between your laptop and your account is the foundation for every cloud lesson ahead. Say each out loud. Here is the lesson in one breath. Install the CLI once with brew install OSCLI. Create access keys in the IAM console, and copy the secret key immediately, because it is shown only once. Run AWS Configure and answer the 4 questions: key, secret, region, output. Then verify with AWS STS get caller identity. When you see your account number, your laptop is connected to your AWS account. From this point on, every AWS command and every Boto 3 script can reach your cloud resources. Install, configure, verify. Next lesson, we answer the question at the heart of this section: what is AWS Lambda? We explain the serverless model, where you write a function, upload it, and Amazon runs it on demand without you ever touching a server. We introduce the handler pattern that every Lambda function follows, and the event and context objects that flow through it. We also discuss the pricing model and when Lambda is the right choice versus when it is not. The connection is ready. Now we put it to use. Lambda is next. If you want hands-on practice now, do these 4 steps. Install the CLI with brew install OSCLI. Create access keys in the IAM console. Remember to copy the secret key immediately. Run AWS Configure and answer the 4 questions. Finally, verify with AWS STS get caller identity. When you see your 12-digit account number printed as JSON, you are connected. That output is your green light. Every lesson after this one assumes the connection works. 4 steps to green. Thanks for connecting your laptop to AWS. Next we learn what AWS Lambda is and why it fits Python perfectly. You are connected.